Hi, welcome to the video demo of DistFax, a systematic toolkit for measuring common distributed systems focusing on the interprocess communications. Before getting into the demo itself, let me first give you some brief background. Our tool focuses on the interprocess communications, IPC, an important aspect of the distributed systems for systematically understanding behaviors and quality of the systems. Our tool computes two kinds of IPC metrics. The coupling matrix measures the runtime message coupling, runtime class coupling, class central coupling, interprocess reuse, class communication load. The cohesion matrix measures the process level cohesion. All these metrics together capture behaviors of distributed systems at runtime. This is the architecture of DistFax toolkit. Our tool takes two kinds of inputs and go through 4 phases to compute IPC metrics, and then provide a quality classification based on these IPC metrics results. In particular, the first phase instruments the system to probe methods for monitoring method execution events. And after that, in the second phase, during the tracing, DistFax performs the executions of our original system. Next, DistFax profiles the execution by tracing execution events, and after that, DistFax computes all 6 IPC metrics. Then DistFax computes different quality metrics. And in a separate workflow, DistFax profiles a training set of other distributed systems executions to compute the same IPC and quality metrics. Our tool computes correlation between two groups of metrics and then construct classifiers for quality metrics. Eventually, the tool predicts the quality status, normal or anonymous, as the final classification output. In the first place, I'm going to show how our tool computes all these IPC metrics. First, let's go to the tool website. After downloading and installing DistFax, we download and install the demonstrating subject Apache thread. We have developed a calculator application using Draft in the subdirectory bin. Now to compute the metrics. The first phase is instrumentations, to insert probes to monitor method execution events. After this is done, the instrumented system file can be found here. Next, the second phase is tracing. In this phase, we execute the instrumented subject with the given inputs and obtain the execution trace. The shell starts a thread server and a client. Then the client sends computation commands and receives the result. From these traces, DistFax now compute the IPC metrics RMC, RCC, CCC, IPR, CCL, and PLC. Then we compute raw quality matrix execution time, dichromatic complexity, attack surface, information flow path count and length. Now DistFax computes correlations. In the last phase, classification, DistFax first checks whether learning models classifiers exist. If it exists, DistFax directly loads the models for classification. Otherwise, it trains the models first. For supervised learning, DistFax uses the bugging algorithm by default. DistFax also provides unsupervised learning based on k-means clustering for classifying quality metrics. Lastly, based on these results, we can see Thread has normal level of execution time and a task service, and anomalous level of dynamic cyclomatic complexity. All these results are predicted based on IPC metrics, and this shows how the tool can help understanding the quality status of the system. We have evaluated DistFax against a number of real-world distributed systems and their executions. The results here show the correlation between IPC metrics and quality metrics, and classification effectiveness, including precision, recall, and F1 accuracy of each classifier. The numbers suggest promising performance and usefulness of DistFax. For more details about DistFax, please check out the tool website. Thank you for watching.